Here we go. Question 1. Compare what is asked to what is offered. Immutable Ledger app needs to build an application that requires a verifiable, transparent, and cryptographically immutable transaction log. This log will record financial transactions, and it must be impossible for any party to covertly delete or modify entries. Which AWS database service provides these characteristics? Select one answer. Review the answer choices on screen. The correct answer is option A. Central Trusted Authority is the phrase that does the work. Amazon QLDB is a fully managed ledger database that provides a transparent, immutable, and cryptographically verifiable transaction log. Unlike blockchain frameworks, where there might not be a central authority, QLDB is designed for systems of record where a central trusted authority owns the ledger. Its journal is append-only and cryptographically chained, ensuring data integrity and verifiability. What's going on, everyone? Stack lessons here. Another 10 for the practice pile. Today on SQS decoupling patterns, VPC peering, and cost-optimized compute. Read each question carefully. Pick your answer in the 6-second window, then check your reasoning against the explanation. Let's dive in. Keep a running tally. We compare scores in the comments afterwards. Next up, question 2. The verb matters here. ImageFlow Pro's web app lets users upload images to S3. S3 events trigger an SQS standard queue, which then invokes a Lambda to process images and email results. Users are getting multiple emails for each image upload, indicating Lambda is invoked multiple times for the same S3 event. What's the least operationally burdensome fix? Select one answer. Review the answer choices on screen. The correct answer is option B. FIFO dedupe happens at the queue, not in your code. SQS FIFO first in, first out queues are designed for exactly once processing and provide message deduplication capabilities. By switching to a FIFO queue and ensuring a unique message deduplication ID, which can often be derived from the S3 event details like object key and e-tag, is used when messages are sent to grow. The queue, you can prevent the SQS queue itself from delivering duplicate messages to the Lambda function. This addresses the root cause of multiple indications with less custom code than Lambda-side idempotency. Here we go. Let's check question 3. Quick check. Managed Grafana Prometheus needs a solution to visualize and analyze metrics and logs from their containerized applications running on Amazon EKS. They prefer to use open source tools like Grafana and Prometheus, but want a managed offering to reduce operational overhead. Which AWS services provide managed versions of these tools? Select one answer. Review the answer choices on screen. The correct answer is option C. Managed Grafana and Prometheus are named exactly that. Amazon Managed Service for Grafana, AMG, is a fully managed service that provides a scalable and secure Grafana workspace, allowing you to create dashboards to visualize metrics from various data sources. Amazon Managed Service for Prometheus, AMP, is a Prometheus-compatible monitoring service that makes it easy to monitor containerized applications and infrastructure at scale. It handles the ingestion, storage, and querying of Prometheus metrics. These managed services reduce the operational burden of running and maintaining Grafana and Prometheus yourself, while allowing you to use these popular open-source tools. Next up, question 4. One detail changes the answer. EFS performance tiering uses Amazon EFS for a file share accessed by multiple EC2 instances. Some data is accessed very frequently, while other older data is accessed rarely. They want to optimize storage costs without sacrificing performance for frequently accessed files. What EFS feature should they utilize? Select one answer. Review the answer choices on screen. The correct answer is option B. EFS tiering moves cold files automatically, just like S3. Amazon EFS Intelligent Tiering, implemented via EFS Lifecycle Management Policies, automatically optimizes storage costs for EFS file systems. It monitors file access patterns and moves files that haven't been accessed for a user configurable period, e.g. 7, 14, 30, 60, or 90 days, from the EFS standard or EFS one-zone storage class to the more cost-effective EFS infrequent access, EFS EA or EFS one-zone storage class. If a file in an IA storage class is accessed, it is automatically moved back to the standard storage class. This provides a balance of performance for frequently accessed files and cost savings for infrequently accessed files without manual intervention. Now, question 5. Start with what the user needs. Legacy Compute Corp is migrating a distributed application to AWS. The current system has a primary server dispatching tasks to multiple compute nodes. The goal is to modernize this into a resilient and scalable architecture on AWS to handle variable workloads. How should a solutions architect design this modernized system? Select one answer. Review the answer choices on screen. The correct answer is option A. A load balancer routes the queue buffers and decouples. Decoupling the job submission from processing using an Amazon SQS queue enhances resilience and scalability. EC2 instances in an auto scaling group can pull jobs from the SQS queue. Configuring the auto scaling group to scale based on the queue depth, number of messages, allows the system to automatically adjust the number of compute nodes in response to workload variations, ensuring tasks are processed efficiently. First 5, the right service owns the problem domain. FIFO for dedupe, queue depth for variable scaling, AMG plus AMP for managed observability. Now, let's go to question 6. SAPA Target Co. runs an application on EC2 instances across multiple availability zones. These instances are part of an auto-scaling group fronted by an application load balancer. The application's optimal performance is achieved when the CPU utilization of the EC2 instances is maintained at or near 40%. How can a solutions architect ensure this desired performance level is consistently maintained across all instances in the group? Select one answer. Review the answer choices on screen. The correct answer is option D. Target tracking chases the number you set automatically. Target tracking scaling policies in AWS Auto Scaling allow you to select a specific scaling metric, such as average CPU utilization, and define a target value for that metric. The auto scaling group will then automatically adjust the number of EC2 instances, scaling out or in, as necessary to keep the chosen metric at, or very close to, the specified target value. Setting the target for average CPU utilization to 40% will dynamically maintain the desired performance level. Let us keep moving. Question 7. The condition is doing work. Inter-VPC data transfer has two VPCs, VPC-X and VPC-Y, located within the US West 2 region and under the same AWS account. The company needs to enable network traffic flow between resources in these two VPCs. It is estimated that approximately 500 GBs of data will be transferred between these VPCs each month. What is the most cost-effective and direct AWS networking solution to connect these two VPCs for intercommunication? Select one answer. Review the answer choices on screen. The correct answer is option A. Transit Gateway costs $36 per attachment, plus per GB fees. VPC peering allows private network connectivity between two VPCs, enabling them to communicate with each other as if they are on the same network. For two VPCs within the same AWS account and the same AWS region, VPC peering is a very direct, simple to configure, and cost-effective solution. Data transfer over a VPC peering connection within the same availability zone is free, and across different availability zones within the same region incurs standard regional data transfer charges, which are generally lower than data transfer over the internet or more complex solutions for just 2 VPCs. After establishing the peering connection, route tables in each VPC must be updated to enable traffic flow between them. Time for another one. Question 8. Look for the answer that fully satisfies it. Dataflow Systems has an ingestion workflow involving an Amazon SNS topic for new data notifications and an AWS Lambda function for data processing and metadata recording. This workflow occasionally fails due to network issues, causing the Lambda to miss data unless manually rerun. What combination of actions should be taken to ensure all data is ingested reliably? Choose 2. Review the answer choices on screen. The correct answers are option B and option E. SQS buffers the failure. Lambda pulls when it's ready. Subscribing an SQS queue to the SNS topic provides a durable buffer. If the Lambda function fails or is temporarily unavailable, the message remains in the SQS queue. Modifying the Lambda function to pull this SQS queue allows it to process messages at its own pace and retry processing in case of transient failures, ensuring all data notifications are eventually processed. This looks like a dead letter queue question, but the real fix is a message buffer. Imagine Lambda crashes during a 10-minute network outage. Messages flow from SNS, but Lambda can't process them. Without a buffer, those notifications have nowhere safe to land. Now add SQS in the middle. SNS delivers each notification into the queue. SQS is durable, so messages sit there safely even if Lambda is completely down. When Lambda recovers, it pulls and processes each one. If a message fails during processing, the visibility timeout kicks in and it returns to the queue automatically. Option C, a dead letter queue on the SNS topic, sounds similar, but that only catches messages SNS couldn't deliver at all. It's a dead end, not a retry mechanism. That's the trap. SQS is the buffer that gives Lambda time to process every message. Time for another one. Question 9. Ignore details that do not change the decision. Inter-Account to Connect, Inc. has an application running on an Amazon EC2 instance in VPC within one AWS account. This application needs to securely access files stored on another EC2 instance located in VPC, which is in a different AWS account. Key requirements are secure connectivity that avoids single points of failure and is not constrained by typical VPN bandwidth limitations. Which networking solution is most appropriate? Select one answer. Review the answer choices on screen. The correct answer is option B. Cross-account peering works, accept the request en route. VPC peering provides a direct, private network connection between 2 VPCs, even if they reside in different AWS accounts. This is known as inter-account VPC peering. Traffic exchanged over a VPC peering connection uses private IP addresses and does not traverse the public internet, ensuring security. Peering connections are designed to be highly available and typically do not impose the same bandwidth limitations as VPN connections might. After the peering request is accepted by the owner of VPC, route tables in both VPCs must be updated to direct traffic destined for the peered VPC through the peering connection. And security groups must be configured to allow the specific traffic flow between the EC2 instances. Let's slow down here. The cross-account VPC question is a classic exam trap worth understanding properly. Imagine 2 offices, New York and Tokyo, that need a direct private cable between them. That's VPC peering. 2 VPCs, 1 private link, no internet traffic. It works across AWS accounts too. VPC's owner just approves the request. Then you update route tables on both sides and traffic flows privately. No bandwidth cap. No single point of failure. Compare this to Transit Gateway. Think of it as an airport hub. Great when 10 or 20 VPCs all need to talk, but overkill for just 2. Site-to-site VPN caps hard at 1.25 gigabits per second per tunnel. That fails when the question rules out bandwidth limits. When the question says 2 VPCs, secure, no bandwidth limits, VPC peering wins. Ready? Question 10. Watch for must, most, least, or accept. Data pipeline on demand needs to perform on-demand data processing for analytics. This processing task can typically take several hours to complete. The results generated by this processing task need to be stored durably for future access. The company is keen on minimizing the cost of running this infrequent but long-running task. Which compute and storage solution will best meet these requirements for cost-effective, long-running, on-demand processing with durable result storage? Select one answer. Review the answer choices on screen. The correct answer is option C. Several hours kills Lambda at the 15-minute ceiling. For tasks that are long-running, several hours, and can tolerate interruptions, as EC2 spot instances can be reclaimed by AWS if capacity is needed elsewhere, though often with a 2-minute warning. Spot instances offer the most significant cost savings, potentially up to 90% off on-demand prices. If the processing task can be designed to be fault-tolerant, e.g. by checkpointing, or being able to restart from where it left off, or if restarting the entire job upon interruption is acceptable for a non-time critical task, spot instances are highly cost-effective. Storing the final results in Amazon S3 provides a durable, scalable, and cost-effective storage solution for the output data. This combination is generally more cost-effective for very long, interruptible batch jobs compared to using Fargate, which might become expensive for multi-hour tasks, or Lambda, which has a 15-minute maximum execution time. Let's slow down here. The spot versus on-demand cost difference is bigger than most people expect. Imagine you have an 8-hour data crunch job that runs once a week. You want it done cheap. Lambda is off the table. Hard 15-minute timeout. That kills option B. On-demand EC2 works, but you pay full price. Elastic Block Store, EBS, costs about 4 times more per gigabyte than S3. That's extra waste for results you just need to store. Spot instances are the key insight. Your job runs for hours on the cheap. When it finishes, dump results into S3, durable, cheap, always accessible. The exam rewards knowing that Spot plus S3 is the winning combo for long, cheap batch work. 3 takeaways from this session. First, SQS FIFO's built-in deduplication beats Lambda-side DynamoDB idempotency for lowest operational overhead. Second, VPC peering costs nothing intra-AZ. Transit Gateway adds $36 per attachment, avoid TGW for 2 VPCs. Third, Lambda's 15-minute ceiling disqualifies it from multi-hour batch. Spot instances cut those costs up to 90%. These last questions share one rule. Hard constraints point to the right answer. 2 VPCs means peering. Several hours means spot. Trust the constraint, resist the feature creep, and the hardest architecture questions get a lot easier. Quick one before you leave. If this is sharpening your prep, hit subscribe. It's the best free way to help these grow. Drop your score in the comments and flag any question worth a deeper dive. Want me to cover a specific exam next? Just say so below. And if the speed or style could work better for you, I genuinely want that feedback.